to another old steam-powered machine shop. Got some serious work done on the planer this week, and a couple of major steps closer to having a 120-year-old planer operational under steam power in this shop. And I want to thank all the viewers that were interested in this project and that contributed toward it, and we're getting close. I had to remove the top housing in order to get the feed rack out and remake it. So that was a little bit more time consuming than I thought it would be. And I had to make a new shaft for it because I had to cut the old one out. So the rack went in, got a new pinion gear made for it, made some bushings for some of the gearing on the side here, and had a local job in the shop that I showed you on the last video. Tractor head to plane, and it seemed like a perfect job for the G&E shaper over here, so I got it set up on that and did that. I showed you that. So we'll get right to the program. Thanks a lot for watching. I'm all steamed up today working on the planer. So I got a little job here for the small lathe, and I'm going to run it on electric. As you can see my motor hiding over there. It's set up so I can run it either off the line shaft or with the electric motor. I just want to clean up this center hole, so I've got a very small center drill in here, and I've got it set up on the steady rest. And I'm just going to go in there and clean this hole up. Got the shaft in here, and I'm actually indicating it in by the diameter that the gear presses onto, not the worn part of the shaft here that I'm going to turn. So I'm using a right-handed ground tool here because I want to get up close to this shoulder, so I'll be feeding from left to right. And this is the tool. You can see the angles. High-speed steel, nothing special. I'll leave that off. see where the wear was on that. Right next to the end of the bushing. There you can see the characteristic finish of wrought iron. No matter what you do, you can't get a really good finish on it. And that's straight within a 1/2 thousandth end to end. Give it a little polish and we'll get started on the bushing. This is a brass bushing that I had for some reason, and it's going to be long enough to make the 2 bushings for the housing piece. And I already bored them that to this OD, so I just got to get the inside out to 1 inch 47 thousandths, which is what the shaft turned out to be. Cutting the back side of the rack on a big vertical milling machine. It's got it down to 810. Move the clamp to finish the cut. These are 40 thousandths per pass. thing I was a little concerned about was machining off the one side of this rack, if it would relieve the stresses on one side and make it warp, because it was really straight when I started, and it did a little bit. About 18 thousandths in the middle. So I'm going to put it in the press and play with it and straighten it. This is a little job I got to get done for a customer on a newer G&E shaper. I thought you might like to see how it worked. This shaper has a 32-inch stroke, and this is a Farmall M tractor head, and the guy pulls it in a stock class, and the rules allow for milling the head, but they don't say how much, so we're taking 1/4 of an inch off it, get the compression up a little bit. I've already done the valves, and so this will be the first job. This shaper is done since it's moved into its new position next to the planer, and you can see how I got it clamped down here. Right now I'm just taking a skim cut, about 10 thousandths off the top, to see how my setup is. See how screwed up the head is here. It doesn't clean up in a few spots. It's got some pretty low spots right in there. This was kind of a lucky setup in that the valve guides that stick through the other side dropped right down into one of the T-slot grooves. So it's sitting on the top machine surface, which is supposed to be parallel to the bottom machine surface. I'll get this cut done, and then I'm going to take a pretty good cut. slowed down here for a finish cut. I changed the tool to a broad round nose tool and slowed the feed down to about 20 thousandths per pass. I don't know if you can see it, but that's a pretty good surface finish there for a clunky old copper gasket. Found a piece of 15/16. Got it trued up, centered, faced. There's the drawing of the end of the shaft that goes across the top of the planer. This diameter here is 15/16. Then it goes down to 790 for 2/830. Then it goes down to 628 for 1/350. That's for the crank, and that will have to have a keyway cut in it. And then this on the end is just a smaller half-inch diameter that's threaded 1/2-13 for the nut. The nut's about a little less than 5/8 thick, so if we leave a thread sticking out of it, that should be fine. So I'm going to start laying out these diameters, starting with the smallest. So to lay these out, smallest first. This is not really critical dimension because it's just threaded for the nut. And then the next one is 1/350, and I'm going to leave it a little long because I can adjust it from the end by facing the shoulder off. And this one has got to be pretty close because when the crank is tightened down, it still has to have some end play against that shoulder. Just step this one off. Next one is 2.830. And that's also going to be left just a little long. And I can adjust them all up on the finish cut. The tool is a piece of 3/8 high-speed steel, and you can see the angles. third diameter here goes to 790. You can very easily grind up your own threading tool. All you got to do is make sure you're right at 60 degrees. To set up the thread gearbox on this lathe is just as easy as pie. You come over here and you find 13 threads per inch. So you put the tumbler in that notch, 13, and then you go out here and the handles have got to be in the B, D. Oh, I can't shift it unless it's moving, but that's got to be over to the D, and that one's got to be to the D, and you got to have this over on the thread. Change it from the feeds to threads, and that should do it. We'll see. Okay, we got an odd thread, so we got to go every quarter revolution. So I could either go on the numbers or on the lines. Either way, if I'm going on the numbers, any number. We got it in a real low back here to start out with. Locked it in. Back into 140. Give it a couple thousandths on the compound. Oh, didn't quite do it. Speed it up a little bit. some reason this original 1/2" nut is so screwed up, and if you look at it you can see the hole was not even in the center, but here's a new one. And it goes on fine. So what I'll probably do is put this nut in the lathe and make it look like this one, you know, rounded like the old nuts were. Got the shaft set up in the milling machine here to cut a 1/8" keyway for the crank. So I've got the cutter centered up and I've got it cranked in 62 thousandths for half of an 1/8" square key. I believe that should do it. That finishes out the top shaft. Have to ream the gears out to 7/8, and that'll be ready to go back in. Seven-eighths reamer. I just laid these gears in here so you can see how it goes. When I put this shaft back in here just now, I remembered that these two bevel gears were opposing each other like this. And I got to thinking, wait a minute, that can't be that way, because if it did, one shaft would run one direction and the other would run the other. And I went out and looked, and sure enough, one of the lead screws is left-handed. Why they would do that and make more trouble for themselves, I don't know. But anyway, this is a 15/16 shaft now. This hole just cleaned up fine, and the gears are reamed for 15/16. And I think I'm going to broach a small keyway, a 1/4 inch keyway, in each one of these gears, and put a 1/4 inch keyway in the shaft, just for future reference in case I decide to do something different than just clamping the gears on with set screws. I don't think that with 41 teeth down here and an 8-pitch screw, it could be that critical on getting these two timed to each other, but we'll see. You know, in either case, one of them could be keyed and the other one could be adjusted. We'll see how it goes. I decided to put a key in this gear. If it doesn't work out, I can always pull the key out, but I decided to put one in. Of course, I didn't have a broach bushing for 7/8, so I made one. And as Adam Booth has said on his channel, he's made hundreds of these things for odd broach jobs. You need to make it so that this will just start in, and I made it so it would go in a couple, so I can line up the broach with the hole, get it started. Okay, a 1/16 inch thick shim. We'll make it an 1/8 inch deep total. And that's set up for our second pass. Okay, there it is. 1/8 inch deep, 3/16 key. It's the top piece ready to go back on. Yeah. Okay, the gear mechanism is back in place, and I'm checking, it's hanging on the feed screws, so I'm checking the synchronization between the two C's. The shaft and the gears are back together and in place up here, and I'm checking the synchronization between the two feed screws. The cross rail is actually hanging on the screws now, and I've got a gauge over here on the top. That will just slide over. Try it on this side. And it looks like about maybe 20 thousandths low. So I'm going to disengage the gear on this side and screw this in a couple of teeth on the gear. That's what it looks like together. This gear here is in pretty bad shape, but it's working. Touches it. Still just a hair low over on this side. Probably about 5. About half as much as I did that time. Okay, it just touches. I'm gonna call that good for now. When we get running it, we can fine tune it a little more if necessary. Success.